Hello, this is Rubab, your audio navigator. I'm here to help you out in the preparation of GATE exam, Life Sciences. As you must be knowing, it consists of 5 fields in which one is compulsory, that is chemistry, and the rest of them are optional, in which you have to select any two. From biochemistry, botany, microbiology, and zoology. The selection from the optional fields you can do easily according to your streams or interest. Before moving ahead, I would like to tell you about very briefly that how to prepare for the exam and what are the points you should be taken care of. GATE exam is mainly about the basic concepts. The aim of the question setters of the exam paper is to make out how well you know your basics. And the question paper could be divided into 4 parts like recall, comprehension, application, and the fourth one is analysis and synthesis. So I will start here with the compulsory topic, that is chemistry. For your convenience, that has been divided into 8 sections. So I will start covering them one by one. First of all, we will cover atomic structure and periodicity. For this, you need to clear your basic concepts about this. Questions mostly asked from this area is of 1 mark. We will start with Planck's quantum theory. So for this, first of all, you need to know a little background about this. For example, in 1864, James Clerk Maxwell established the wave nature of electromagnetic radiation, which could explain interference and diffraction, but could not explain the black body radiation and photoelectric effect. Then you should go through the theory which was given by Planck in 1900. You should also know the formula for the spectral radiance of a body at absolute temperature. What is Boltzmann constant, and then what is Planck's constant. For this, you also need to be well aware with the terms like photoelectric effect, quanta, photons, electromagnetic radiation, photoelectric effect, etc. You should also know the value of Planck's constant and practice out various numericals based on it. After this, you need to understand the wave particle duality, how and where sometimes one theory is used and the other, sometimes the other. You should also know what are the contributions of different scientists in this field. What are the theories given by J.J. Thomson, Faraday and Maxwell. Photoelectric effect given by Albert Einstein. What is de Broglie wavelength? What is the formula for that? You should know the derivation. What are the properties of light for which it could be considered as wave or for which it could be considered as particle? So you should be well aware of the properties of light corresponding to each nature. You should also know the whole electromagnetic spectrum with the corresponding wavelengths. After that, you should also know the Heisenberg's uncertainty principle, the derivation for that, the basic principle. Then what is de Broglie bomb theory? Then also you should know that was the wave behavior of large objects. Then what are the alternative views like both particle and wave view? Then there is wave only view, and then the particle only view, and then there is neither wave nor particle view. So you should go through these. And what are the applications of wave particle duality? It is used exploited in electron microscopy. neutron diffraction, etc. Now comes the quantum mechanical model of hydrogen atom. For that, you need to start with the atomic or molecular spectra. How does the hydrogen atom spectrum look like? Then what is the Bohr model of hydrogen atom spectrum? What is the Bohr frequency condition? What is Rydberg formula? So you should know about all these terms and how Bohr explained and the concept behind the hydrogen atom spectrum. What were the Bohr's solution? For example, like quantization of angular momentum leads to quantization of radii, that is Bohr orbits, or leads to quantization of energies, and assume the Bohr frequency condition and yields the same Rydberg formula for allowed energy levels. Then what is Schrödinger equation? Derivation and the formula, the interpretation of the wave function, and how the wave picture justifies Bohr's assumption for hydrogen atom. What is the Schrödinger equation for hydrogen atom? And wave functions for hydrogen atom. The concepts about s, p and d orbitals, it should be very clear for you to understand its properties. And you should be also very clear about the separation of spin components. That are the features going beyond the Schrödinger solution. So the points which I just mentioned are important from this topic. Go through them, especially the basic concepts. Then the equations are also important, as for example wave function and for energy levels, etc. After this, you need to go through the electronic configuration of atoms and ions. For that, you should know what is actually electronic configuration based on atomic physics and quantum chemistry, and how it is useful in understanding the structure of periodic table of elements. What is the concept of shells and subshells? What is the principal quantum number? That is n. And what is azimuthal quantum number, which is L? What is the expression for the maximum number of electrons that can be placed in a subshell? And what would be the maximum number of electrons present in a particular subshell? What is Pauli exclusion principle? So you should know how to indicate the electronic configuration of atoms and molecules for a particular atomic number, which is frequently asked in the GATE exam. You should also know what is the Madelung rule for the configurations of neutral atoms. And you should also know the configuration related to the ground state and the excited states of the electron. Then what you need to know is what is Auber principle. Then there are a few shortcomings of Auber principle. You should know about them. Then what would be the electronic configurations after the ionization of the transition metals? How it is done and what are the theories related to it? Then there are electronic configuration filled in violation of Madelung's rule. So you should know about these also. After that, what are the application of electronic configurations? So these were the points which you need to go through for the electronic configuration in the exam, which is frequently asked, the electronic configuration of particular atom. Now I will tell you a few points which you need to take care while writing an electronic configuration for atom of any element. So what are these points? First point is find your atom's atomic number. Then determine the charge of the atom. Then memorize the basic list of orbitals. Then understanding the electronic configuration notation, memorize the order of the orbitals. Then fill in the orbitals according to the number of electrons in your atom. Use the periodic table as a visual shortcut. Learn shorthand for writing long electronic configurations. So these points will help you in determining the electronic configuration of a particular atom of element. Now moving to the periodic table and periodic properties. First of all, go through the little bit history about periodic table. Then we should know how the periodic table is organized. What is the main basis of organizing it? Then how are the periods formed in the periodic table? Then how are the groups formed? Then what are the representative elements of each group? Then what are the S block, D block, P block and F block elements? Where they reside in a periodic table? Then after that, what are the different families like alkali metals, alkaline earths, transition metals, post-transition metals, semi-metals or metalloids, then halogens, noble gases, lanthanides, actinides. So you should know what is the basis of classification of these families, what are their characteristics. The best thing is if you are able to memorize the periodic table, then do it. It will be very beneficial for you and will solve a lot of problems. Then you should also know how the electron structures shape the periodic table. The shell model of the atom, you should know about it. Then what are the effective nuclear charges of the elements? How it is calculated. You should know about this. Now moving to the periodic trends. First of all, the trend in electronic configuration. What is the trend usually seen in electronic configuration with the increasing atomic number? And as you know, it is done with the help of Mendeleev rule. Next comes the atomic radii. Should be well aware with the terms covalent radii, ionic radii and metallic radii. So what is the trend for all of these through a period and through a group in the periodic table? And how does the ionization affect the atomic radii? You should also be aware with the term lanthanide contraction. How does it affect the radii? Now after that, the trend in ionization energy. So you should know what is the pattern of ionization energy along a period in the table and along the group. And what's the difference between first ionization energy and the second ionization energy? And likewise the third and the fourth. So how does it differ from element to element? The next trend which you need to study is electronegativity, which generally increases along the period and decreases along the group. And there are some exceptions also to the general rule, so you should know about them. The next trend is electron affinity, which generally increases along the period and decreases along the group. Where is electron affinity positive and when it is negative? Then how does it vary from non-metals to metals? So you should also know that going down through the group, electron affinity decrease is not uniform. The uniform decrease in electron affinity is only shown by the group 1 atoms. So you should go through what are the other factors affecting electron affinity. Now the next trend which you need to study is the metallic character. You should know what is the trend which it follows in a periodic table. So what is the basis of metallic character and how on this basis the elements can be divided into metallic and non-metallic, metalloids, etc. So apart from these main trends, there are a few other properties also which follow a trend in periodic table. For example, melting points, then the redox potentials, the oxidation potential, and the reduction potential. So you should also know that what trend do these follow. Then after that you should also know that where the knowledge of the periodic properties of elements can be useful. For example, in predicting greater or smaller atomic size and radial distribution in neutral atoms and ions, measuring and comparing ionization energies, comparing electron affinities and electronegativities, predicting redox potential, in comparing metallic character with other elements and knowing its ability to form cations, also in predicting what reaction may or may not occur due to the trends, determining greater cell potential between reactions, and also in completing chemical reactions according to the trends. So this was all about the periodic table. The periodic table as well as the trends in the properties which it follows, both are very important. Small 1-mark questions could come from this field. Time taken for its preparation is around 2 to 3 days. I hope the information which I shared with you is going to be helpful for you. Thank you.